I am not teaching, I am publicly learning. But hi and welcome to Learning for the Life in the UK test, part 209, Notable British Sportsman and Woman, part 4, that is on page 74. While doing wrist training, and if you participate in wrist training, that is at your own risk. We were just talking about what ice skating is, and I just heard all this, I have checked it for myself. But the thing is that frozen water is ice, and ice is slippery, and it's especially slippery if you have special ice shoes. Ice shoes, they are like normal shoes, but when below them there's out of metal or steel or something, there's a thin thing. So you're not standing on such a big part of the foot, but just on a very thin part, just a steel thing. So there's just a foot, and then down there there's a metal thing. It's like this thick, and then that. And so you're not just standing on the big foot, but on a very slim, thin line. And now, as far as I know it, I haven't checked it myself, but if on ice comes pressure, it melts. It's very, very little, you can't see it with the eye, so you will not see it. And now with a very thin film of water is now, you can slide on it. I actually don't know. It might be about the atoms or something, but I don't know why water is that slippery. So the point is you could slide over ice. And by ice dancing, the people have made a big stadium, and then they had put water there, which is then frozen. And it's very thin, they take very much care of it, that it's completely thin inside. And now these people have these shoes, and they are dancing on this ice. Now they're basically dancing like on the ground, but on this slippery floor. Now it is slippery and it's dangerous, you can fall, but if you know how to do it, you are pretty secure on that ice, and you can make completely different things when on ground. On ground you can also turn into pirouettes and something like that, but on the ice you can, it's more like flying. So people describe often things as flying or floating or flying, and dancing can feel like flying, but in a way you still have to use your own feet. On the ice, as soon as you have speed, so you can start running, if you know how to start running on the ice, where you're not putting the ice things like that, and when you would fall down, you're putting them like that, and then you can push to the side. And you have the big part. So if you're like that, you can just slide over it. If you have the back, you hold much more. And then you can jump there, and after you have speed, you can just slide over the ice. You have very little friction on the ground. Basically, you're just only slowing down through the air which you're coming against. And you can then, after you have some speed, actually for 50 or meters or something like that, or 20, 30 meters, so quite a long distance, do nothing, and just stand there, and you're basically just going over the ice. And it's very quiet, the ice, because you just have such a thin thing under the shoe with which you touch the ground. By running, there's all the time a lot of noise when you go onto the ground, and also dancing is loud. You can have quiet shoes and there can be quiet floor. But when you're on the ice, it's almost completely quiet. And you're not moving a muscle, you're just standing there and you're just sliding off the ice, if you know how to do it. So it's actually almost like flying. And now these people, when they are two, and they're dancing actually together, and it's actually like flying. They are turning, they're holding on each other with their hands, and they are lifting each other up. And it's like flying over the ice, they're making curves, and they are throwing the other person into the air and catching them again. They can turn around, and they can turn around completely differently from the ground dancing. When you do a pirouette on the ground, you have to, if dancers make pirouettes in a row for a long time, they have basically every time they're doing a turn, take the leg out and take again pace to make the next turn. Or they can do only for 2-3 seconds, 4, 5, 6 in a row, but then they can't do anymore. If they're dancing on the ice, they have almost no contact to the ground. And now if they're doing a pirouette, there's not so much air wind, so you can actually do way more like that. And one figure, for example, that they are more on the outside, with the arms on the outside, and they are then turning, and when they're taking the arms to the inside, or up, and then because we're taking the mass to them, it's just physics, we're turning faster. So we're just turning slowly with the arms out, or with another partner, and now we're putting the weight of the body to inside, and we're starting just to turn faster. It's just physics. If the mass is closer to the body, now we're turning faster. And what we can make, for example, one figure of ice skating is that we're turning and taking the arms in, and we're turning much faster, they are really fast, and then they're taking the arms again out, and they're again almost as flying. So we're going from flying, then turning, and we're going very fast spinning, and again in flying. And we're doing this in a par dance. They are sliding around the arena. I don't know how big, but 50 meters or something. So it's big. It's like flying. We just take 2-3 steps to get pace, and then we can slide a complete 50 meters. So it's completely different than dancing. And basically that's ice dancing. And Jane Torval and Christopher Dean had done it, and in the Olympic Games in 1984 we won the gold medal. And Jane Torval and Christopher Dean also won 4 consecutive times the World Championships. So by the Olympic Games, these were probably the Winter Games. So there are Summer Games and Winter Games. Every 4 years there are Summer Games, and every 4 years there are Winter Olympic Games. And now we could calculate back when the last one was. And there's always been in 1 year, for example, 1982 was when probably the Summer Olympic Games, and then 2 years later there's the Winter Games. So they are like that. Every 4 years the Summer Games, and the Winter Games every 4 years. They are then 2 years apart. So every 2 years there's Olympic Games. And by the Winter Games there's more of snow and ice. So there's been ski running and these types of sports. By the Summer Games there is running on the ground and swimming, and by the Winter Games there's ski or ice and so on. And then there are also World Championships in ice dancing, and they have won 4 consecutive times, so 4 times in a row, the World Championship. Jane Torval and Christopher Dean. Now we're going to do the complete whole wrist training, and if you participate in that's at your own risk. And then we're going maybe back for 1 or 2 minutes, looking if we have anything else. We are having the hands at the outside, the hands front to fist. Now we bring the fists down, and again up, and again down, and again up. And we're having 3 rules. The first rule is that we are stopping immediately as soon as we feel pain. The second rule is that we're going only as far as we can go for a little bit of effort. And the third rule is that we're not overdoing it. So as soon as we reached our potential, we are stopping it and doing nothing or another exercise. In this case, now that was the spotlight, and now the flashlight. Same setup. Now the fists to the inside and to the outside. And the last time. And now the next exercise. The magician. Flat hands next to us. And bring the hands to the inside and to the outside. And to the inside and to the outside. And now the pancake flipper. Flat hands next to us, and we bring the hands up and down. Again, these 3 rules. We're stopping immediately as soon as we feel pain. We're going only as far as we can go for a little bit of effort. And the third rule, we're not overdoing it, so this will be the last time. Now the quadrangular castle architect. The hands out with flat hands. Now with fists. And let's bring these fists to the inside. And up. And to the outside. And to the inside. Then down. And now to the inside. And now down. And to the outside. And up. And last time. And last exercise. A crab anxious to a fever, where we are next to us, the hand forward to the fist. And we bring the fist down. And we're pressing carefully against it. And we're pulling carefully from the outside. And we're pressing carefully from the top. And from the bottom. Now the other hand, extra, so we bring the hand down and we press carefully against it. And we pull carefully from the outside. A bit at the top. And a bit from the bottom. And now just a bit of relaxation. We go with moderate pressure over the middle part of the top part of the lower arm. And with the other arm. And now we're having 4.5 minutes. Look what is, I don't know why, but for some reason I can remember Jane Tarver and Christopher Dean. Jane Torval, Christopher Dean. Sir Steve Redgrave, 1962, born. Won gold medals in rowing in 5 consecutive Olympic Games and is one of Britain's greatest Olympians. In rowing. I think that happens in the boat. So, to explain now what a boat is. So rowing, that is, we have the people again, I'm not sure if it's rowing, but it must be rowing, what else would be rowing? But there are multiple disciplines in rowing. So, you have the oars, and you have a boat, and you have water, and the other competitors. And so we are all in the boat, and we're waiting for the start. And when we're trying to row over to the other side or far away over a kilometer or something, and who's the fastest over at the other side. So we're having a small boat. I just say it's now a single person, the boat group. So it's a boat, but it's a special boat. These are fast boats, so they are not big. We don't have to transport any goods. We don't have to export textiles. We are just for the person, and they are very thin, these boats, and we are sitting in them, and I'm not explaining what the boat is. And these boats are very, very thin, and we are in them and we're having rows. Sometimes we're having just one, but most of the time we have 2 by rowing. That's around what is meant here. And now we're having an oar, and so the boat is, I'm explaining it more or less, it's basically a hollow object, and if something is on the water, and these boats are hollow on the inside, and they are of course waterproof. So now water can come in them, and they are protruding out of the water. Now the water line is here, and the boat is about it. And now if someone goes into the boat presses down to the ground, but if it's not too much weight, the boat stays over the water. And it can be always so much weight in the boat as the water can push the water aside. So if a boat is high over water and it's just a little bit under the water, then all that water that is pushed away here, of these 2 centimeters on 2 meter length of the boat, is on weight in the boat. So now when it's in, the boat is very light, so it's basically not much, water is very heavy. So they're just 1 centimeter, let's say like that, I don't know what it weighs, maybe 10, 15 kilograms or something, this boat. And if it's a centimeter under the water, and now all the water which is pushed at the sides, that can be as weight there. Now if a person with 70 kilograms, they oftentimes are quite light because they want to be fast and they are athletic, the water is, there's more pressure in it, and now it sinks down the boat, but not completely. The more deeper you want to bring the boat down, the more you need to push against it, the more weight does have to be in the boat. And that's because now more water is pushed to the sides. And water is pushed to the side, and so much water as is pushed to the side at weight, so much weight is in the boat. So if now a person with 70 kilograms comes in the boat, then 80 kilograms, the weight of the boat, are pushed to the sides in the boat, so around 3 centimeters into the water or something like that, or 4 centimeters. Now the boat is swimming. Because the water cannot come over it, to come over the edge of the boat, the water had to come up, but water is not coming up. The water is drawn by the gravitation to the earth, so water is just here. And water is not suddenly come up. So water cannot come into the boat, because it's waterproof. And where should the water go? Now the water comes to the side. When the boat pushes down, the water goes just to the side. And as long as the water surface is not higher as the edge of the boat is floating. And it's sinking. And now there's a person in it, and they're having oars, and the oar is, oftentimes it's just plastic, but let's say it's out of wood. That's, let's say, 1.5 meter long thing. They're having two like this, and they're grabbing the ends of them, and then they're showing them. So it's a piece of wood. I'm going to explain oars in the beginning of the next part. I thank you very much, and until next time.